Hello, I welcome you all. This problem is coming from the Engineering Mechanics Dynamics 14th edition by RC Hibbeler. So I will not read the whole problem. You can read it on your own. I'll just go to the important points. So we are being asked here to determine the vertical reaction the seat of the plane exerts on the pilot when the plane is at A at this point. And the rest of the other information has been given to us. The speed of the aircraft or the plane at A is constant and is 85 meters per second. The path is described by this function r, and then of course the rest is as shown. Great. So let's draw the free body diagram. Of course we do have, so we have the pilot. So we have the pilot seated. So if this is the seat and this is the pilot, so we have the weight of the pilot, and we do have, if we are to separate this, then we do have the reaction from the seat like so, and there like so, right? Can you see this? Okay, so therefore we are looking at the pilot with his weight as well as the normal reaction force from the seat. So this is what we want to show. Okay, great. So there we go. So let's say, let me show the coordinate. We are using polar coordinates. So we do have, this is our radio, and then we have this is our our theta. All right, so this is our theta and this is our radio, right? And then we have the weight. We do have the weight of the pilot. We have the weight of the pilot, and then we have the normal force from the seat where the pilot is seated being exerted on the pilot. Okay, so this is our W, and this is our normal force. Okay, right. Of course, at A here, what else do we need? Basically, this is enough. Let's now find the inputs that we are going to use for the acceleration along the r and the theta direction. So r is just equal to 200 1 plus cos theta, and r dot is equal to 200 minus 1, minus theta sine minus theta dot, which just becomes minus 200 theta dot sine theta. Then r double dot, this is minus 200, we open bracket, using the product rule, we find the derivative of 1 and then hold the other one constant, so we have this expression, right, like so. All right, and what else? At A, theta is equal to, theta is equal to 0, right? is equal to 0, okay, because we are measuring from that point, 0 degrees. But theta dot, we can compute it from our VP. This is our constant velocity, which is just equal to VR squared plus V theta squared. Therefore, our VP squared is just equal to VR squared plus this. And then we know that VR is just R dot, which is just equal to minus 200 theta dot sine theta, right? And our theta node, V theta is just equal to R theta dot, and this is just equal to 200 1 plus cos theta, then we have theta dot. So with this information, we can find what theta dot is. So this is just equal to minus 200 squared theta dot squared sine theta squared plus 200 squared 1 plus cos theta squared and theta dot squared. So let's find the derivatives of this. We know already what VP is, so this becomes we have this like this. This is equal to we have two functions there squared, so this just becomes 2 theta dot theta double dot like so. Okay, sine squared theta, then plus theta dot squared. We're using the product rule here, then we'll have 2 sine theta, then theta dot cos theta like so. Then plus, we've worked on this. Okay, then we go to the 200, so we can factor out 200 like so. Again, we have two functions there, so I'll open up, so I'll say 2 1 plus cos theta. We are using the product rule also there, and then theta dot, then minus sine theta. Okay, minus sine theta, and then this one is constant, then plus this one becomes constant. Okay, then this one just becomes a 2 theta dot theta double dot like so. Okay, square. Now with this, let's work on the first equation, this one here. Okay, so we know that our VP is just equal to 2, is equal to 85, so that we find theta dot, and our theta is equal to 0 degrees. So 0, this part becomes 0, alright, and then this will be equal to 85 squared is equal to 200 squared 1 plus cos 0 degrees squared, then theta dot. Alright, and then our theta dot will just be equal to 85 squared divided by 1 plus 1 plus 1 plus cos 0 degrees squared, then everything under the root. Of course, we do have a 200. We have a 200. Let me move this. We do have a 200 like so. Then we are moving this everything under the root like so. Alright. And this is just going to be equal to, let's work it out. So 85, let me just at 200 I say 1 plus cos 0 is 2, and then this squared times 200 squared, then 85 squared divided by answer, square root of that, I get a 0.2125. Alright, let me just check it through again. Okay, it has happened 2 squared by 200 squared, 85 squared divided by answer, square root of that, 2125. Right, so that's our theta dot. Now let's work on this one. So here this part becomes 0 because of theta, and so is this part becomes a 0 because of theta equal to 0. Then this part also becomes equal to 0, so we just remain with this. Then we know that our VP, like we said, is 85, and then 85 theta is equal to 0, theta dot is equal to 0.2125, and VP dot is equal to 0. So with that information, we can plug in all those inputs so that we solve the problem. So this just gives us 0 is equal to, we are solving this, mind you, we want to find theta double dot. 0 is equal to, this is 0, this is 0, this is 0, so it's equal to 200 squared, and then 1 plus cos 0 degrees, and this is squared, and by 2 by theta dot, which is just 0.2125, and by theta double dot. Theta double dot is just equal to 0, right? Yes, this is just equal to 0. R at theta equal to 0 degrees. This is just going to be equal to 2 by 200, which is 400, and then R dot by theta equal to 0. This is just equal to 0. And then this at theta equal to 0. This is just equal to minus 200 times 0.2125 squared cos 0. And this gives us a minus 9.0325. Okay, 2125 squared cos 0, which is just a 1, times a minus 200. Alright, and then we have the rest. So our ARI is just equal to R double dot minus R theta dot squared, which is equal to minus 90125 minus our R is 400, and then theta double dot is this. Therefore our AR is just going to be equal to minus 9.03125 minus 400 by 0.2125. Okay, so this gives us a minus 27.0938, but I'll write a whole lot of it, 375. Okay, our A theta is just equal to R theta double dot plus 2R dot theta dot. This is just equal to this part is 0, this one. Therefore we just have a 2. R dot is 0 also. So both these two are zeros. So this is just going to be equal to 0, like so. Right. Then we have summation over forces in the arrow direction equal to MA arrow. What do we have? Our acceleration is in that direction, like so. This is our A arrow. Okay, right, and we do have our W, okay, minus our normal force equal to MA arrow. So this just becomes our mass for the pilot is 80 kg by 9.81 minus N, then 80 by minus AR is minus 27.09375. Therefore, N is just going to be equal to, N is equal to plus 80 times minus 27.09375, 9375, minus 80 by 9.81. Alright, so this just becomes a 29.52.3 newtons, and this normal force is going upwards like so. I guess this is about it. Of course, we had to go through this, and to some extent we didn't use this information so much, but just for the sake of knowledge, we just had to go through that, because all this stuff could have been cancelled out, where our ARR, of course, we just needed ARR there, right, for us to work out this. Okay, all right, it's fine. So there we go. We do have our normal force, our normal force, which is the reaction force of the seat on the pilot, or the reaction force exerted on the pilot by the seat. I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye. I'll see you in my next screencast.